Quite often when we talk about the various Nobel Prizes, it's for a very specific piece of work. This particular one in 1928 was awarded to Owen Willians Richardson for his work on the thermionic phenomena, and especially for the discovery of the law named after him, which we'll get to that in a minute. But the way this is worded implies in many ways that it's not just for the discovery of a law named after him, it's for a body of work that led to that discovery, that was not just a single paper or a single experiment or a single theory. It was for a lifetime of contribution to the field. Following J.J. Thomson's identification of the electron in 1897, for which he won the Nobel Prize in 1906, Professor Richardson began work on the topic that would later be called thermionic emission. It comes out of band theory, which is a part of solid-state physics and a theoretical model describing the states of electrons in that material, and says there's basically a fixed number of electrons per atom in a solid that are free to move from atom to atom, and this is sometimes collectively referred to as the sea of electrons. Their velocities follow statistic distribution rather than being absolutely uniform as they make this motion, and occasionally an electron will have enough velocity to exit the material, or metal in this case, without being pulled back in. The minimum amount of work needed to do that must leave the surface. It's called a work function. So there's a big heavy set of mathematics that explains all that. Don't worry about any of that. Just understand that there's a minimum amount of energy needed to get an electron to spring free and fly off. The work function is a characteristic of material, and it changes from material to material. But thermionic currents can be increased and decreased through that work function. And the often desired goal of having electrons kind of spit out can be achieved by applying various oxide coatings to the wire. Now, that's a big fancy pile of stuff. And why do we really care about spitting electrons free of wires? Well, there's a couple of reasons, but there's one everybody probably has seen. Now, in 1880, Thomas Edison invented the light bulb. There's still some argument about whether or not he really invented it or whether it was somebody else, but largely it's credited to Edison, so we'll just leave that for another day. But in 1880, Thomas Edison produced a light bulb that functioned, but actually was taking advantage of this thermionic emission. He didn't really understand it. It was sort of a let's try a whole bunch of stuff and see what works kind of invention. But once the work was formalized and fully understood, those light bulbs lasted a lot longer, those light bulbs got much better, and that emission was able to be utilized in far more places than it was just in the light bulb. But one of the prime examples of a use of a thermionic emission turns out to be the incandescent light bulb. So I hope you've learned a lot in this one. It's kind of a short and sweet one, but this emission is very important. It gave us light in the night rather than having to use torches, which is a fantastic step forward, even though today mostly we use LEDs, which is another step forward. I hope you've enjoyed this video. Please click like and subscribe. It really does help us out with the algorithms. Thank you very much, and we'll see you on the next one.